for 6.3, graphing inequalities. And we've already been doing that, I guess, is one of my first thoughts as I read that title, graphing inequalities, because in section 6.1 and section 6.2, so the previous two sections, we were already graphing inequalities, but we were doing it on a number line, not a plane, not the XY plane. We were doing it on a number line because in the previous two sections, the inequalities we were working with didn't have an X and a Y variable. They just had, say, an X variable, or they just had an N variable, or whatever. Usually it's X, but they only had one variable. Bottom line is they only had one variable. But now, I guess in 6.3, I guess the biggest upgrade here is that we're going to be working with inequalities with two variables. And yeah, just like always, normally the two variables are X and Y, even though they could be whatever you wanted. I mean, we have this XY plane with the X-axis and the Y-axis, which means like pretty much always the two variables are X and Y. So our ultimate goal in this section, and if you've already learned this in the past, then you kind of know what I'm talking about, I guess. But our ultimate goal is to take the inequality and be able to draw the graph. So this is a sort of a different approach, and it's kind of like a, I don't know, it's not like a main question. I don't think you're going to see homework questions like this, and I don't even think you're going to see test questions, at least in this class. I'm not saying you couldn't get a sort of a question like this on maybe the Keystone exam or something, but again, our ultimate goal is not to really answer this kind of question, even though it is important. I mean, if you can't answer a question like this, then I guess there's something that you're not getting or understanding. But anyway, our main task is to take something like this and know the steps to draw the graph. So here the graph is already drawn. Like I said, it's kind of a different approach here to start things off. And the question is, are the following points solutions to y is greater than or equal to negative 2/5 x plus 1? And what does it mean for something to be a solution? Well, it means to plug into the inequality or the equation to make it true. And of course, since this has an x and a y variable, a solution requires a pair of numbers. One number that's supposed to plug in for x, and another number that's supposed to plug in for y. So if you plug 2 in for x and also 2 in for y, does it make it so, for example, 2 greater than or equal to negative 2/5 times 2 plus 1? Like, is that even true? This is going to get you negative 4/5, and when you add 1 to negative 4/5, again, I'm doing this in my head, it's not the best way to go about business, but negative 4/5 plus 1 should be 1/5. So ultimately this is going to say, 2 is greater than or equal to 1/5. Is that true? And yes, it is. And so 2 comma 2 does turn out to be a solution. If you plug in negative 2 comma 4 in for x. I guess why don't we just go ahead and do that as well? Why not? We have the time. So if I plug in 4 for the y, greater than or equal to negative 2/5 times, and I plug in negative 2 for the x. So this right here is going to be positive 4/5 plus 1 is like 1 and 4/5. You know, I don't like mixed numbers, but I know that 4 is greater than or equal to all of this. And so this turns out to be true. 1 comma negative 2, so is negative 2 greater than or equal to negative 2/5 times 1 plus 1? Negative 2/5 times 1 is negative 2/5 plus 1 is 3/5. And so this is a no. So this is a no. So basically, to kind of fast track this and cut to the chase, you know, I know we have the time, but it's probably better if I just kind of cut to the chase here. The graph, remember, is just an illustration. It's a picture of all of the solutions. All right? So 0, 1. 0, 1 seems to be like on this line. And I want you to kind of look at this and remember that it wasn't too long ago, even in this class, that we were doing stuff like, what color do I want here? I'm going to go with, what would be the best color? It probably doesn't matter here. Blue should probably be okay. Now check this out. This is an inequality because it's a greater than or equal to. But what if it was just an equal sign? So what if it was an equation rather than an inequality? Oops, sorry about that. Okay. Now when you graph this, as you should remember from earlier chapters and stuff, this is graphed as a line, okay? And, you know, y-intercept of 1, and then the slope is negative 2 over positive 5. And so we could even go in the reverse. And essentially, if this was an equation, you know, all of these points on this line, okay, solves this. So whatever that point is a solution. Whatever that point is, whatever that point is, whatever that point is, whatever that point is, whatever. I mean, there's points everywhere, literally everywhere on this line. And so, you know, all of these points would also solve this guy, because this says y is greater than or equal to negative 2/5 x plus 1. So as far as the equal part, we got this blue line. But what about the greater than part? It's not just y is equal to negative 2/5 x plus 1. Y could also be greater than. And what that essentially does is it opens the door to even more solutions. And you know where all those solutions are? Up here in the shading, like everywhere. Not just that guy, which is negative 2, 4, which, you know, we checked. Not just 2, 2, which we checked, but everywhere. All, and not even the nice points only. All these weird points with nasty decimal coordinates. Everywhere. And so we have to like shade everywhere, like above our line, because there's even more solutions, you know, like this guy and this guy. So we shade, and essentially that's what the graph is going to look like. It's going to be a line and shading on one side. Because over here, like when you try to plug in, what is this, 1 comma negative 2, we saw that it didn't work. And so we don't shade here. And if we were to plug in negative 4 comma negative 4, I already can tell you it's not going to work because this is not in the shaded area. So basically, down here below the line, there are no solutions. Everywhere is a non-solution. But everywhere above the line is a solution, no matter where you look. All right? And so write this down. Pause the video if you have to give yourself a few seconds to write this down. But we're essentially going to, when we see something like this, it's really all about drawing the correct line based on M and B from mx plus b. So we draw our line, and then there's essentially going to be shading on one side as long as it's an inequality, like a less than or a greater than or a greater than or equal to or whatever. So there's a line and there's shading, okay? And based on the symbol, you might have a solid line or a dashed line. Right? So if you notice with these two symbols, it's a solid line because it contains an or equal to. And that's really the difference. If there's an or equal to, then you make the line solid because all those points on the line are in fact solutions. But if this was just a greater than, think about it. If this wasn't a greater than or equal to, if it was just a greater than, then all of these points on the line wouldn't actually be solutions. Okay? If you plugged in 0, 1, and this was just a greater than, it actually wouldn't be a solution. So for these symbols, you have to make the line dashed or dotted, whatever you want to call it, in order to illustrate that you're not actually including those points in your graph. It's like a ghost line. Like you're drawing the line, but you're really not drawing the line. You're really not technically including it in the graph. So, and then as far as the shading goes, this is really easy because as long as your inequality is written like this, the whole like slope intercept form deal with y on the left and mx plus b on the right, as long as it's written like this, which, it will be, right? It just will be because you pretty much need it to be, well, you don't need it, but you pretty much need it to be in this form to draw your line in the first place. So it's going to be in this form, and as long as it's in this form, if it's a greater than or equal to, or a greater than, like if it's greater than at all, you shade above. And if it's less than at all, like less than or equal to or less than, then you shade below. So greater than you shade up, less than you shade below. It's really that simple. So let's do a couple quick examples. So again, now we're really, okay, it's probably been, I don't know how many minutes already in this video, but like now I guess we're getting to like the real deal. Here's the kind of examples, and here's the quick step-by-step process without so much explanation. So you got to be able to take stuff like this and graph them. So step one is we draw the line. And so our y-intercept is -4, and our m is 1/3. And so we begin with b, and we move with m, so that's rise over run. And we could also go this way. And because of the symbol just being less than, we actually make our line dashed. Because we're not really including all these points. All the points on the line don't actually count as part of the graph. So we make it dashed. And then it's a matter of shading, and because it's a less than, we shade below. Everywhere. And so that is that. You draw the line, you make it dashed or solid, depending on the symbol, and then you shade on one side or the other, depending on the symbol. Now, really quick, before I jump to the next example and the rest of the examples, probably most or all textbooks, will, the way they'll say it is, if to figure out which side to shade, which side has all the solutions. Textbooks will tell you to pick a test point on either side, and if it applies, that you could just pick, like, what do you think? Hint. Sorry. What do you think the easiest point, like ordered pair, right? What pair of numbers would be the easiest to plug in here to see if that point is or is not a solution? What point would be the easiest? Well, 0, 0. If it, unless it falls right on the line, if 0, 0 actually is on the line, you can't really use it as a test point on like either side, right? But here we could have tested 0, 0 in here to actually see if it's a solution. And in this case, it would have turned out that it would not make it true. And so if this is not a solution, then nothing on this side of the line is a solution, and then you would shade the other side. If 0, 0 checks out, or whatever test point you're testing checks out, you can shade that side. But I like to go with you should understand that, obviously. But I just like to go with, if it's less than or equal to, you shade below. If it's greater than or equal to, you shade above. And there's literally only one case where that doesn't work out, and that's a little bit of a foreshadowing, but maybe we'll get to that in this video. I don't know. We'll see. So example 2. So what's our b value? mx plus b. So b is 0. This might as well say plus 0, right? And m is, looks like a Mr. Humphreys m. That is unacceptable. Rise over run, so we might as well give it a run. And so, hold on. And so begin with b, move with m, down 2, negative 2, over 1. Might as well make as many points as possible. So now we're drawing our line, and because of the or equal to, it's going to be solid. Because all these points count as solutions. And now we just have to shade on one side. Now, I feel like I got to point this out one more time. We could do a test point, but guess what? We can't really test 0, 0. 0, 0 is not on either side. It's right on the line. So we'd have to pick something else, like 1, 1 or something. But we don't have to do that here. If it's greater than or equal to, we shade above the line. Right? Right. Or, some people, if you don't like shading thoroughly, then, a lot of people just kind of do this. That gets the point across, or something like that, different styles, whatever. Example number 3, well, okay. So here our b value in mx plus b is 3. Our m value, mx, what number's in front of the x? It's a 1. And since slope is best as rise over run, just put it over 1. And so we begin with b, we move with m, up 1 over 1, And then we might as well keep that going even in the other direction. Want our line to be the bestest line it can be. And since it's just greater than, then we make it dashed or dotted. And as far as the shading goes, it's a greater than, and so we shade above. So if we were to test 0, 0, or even 1, 1, or it would have turned out to not be a solution, and so we would have shaded the other side. But I like the above or below deal. Aha! Where's the y variable? Well, remember how there's certain special case equations / inequalities where there might just be only a y variable or only an x variable, and it still could be a line in the plane. Do you remember? So this is a horizontal or vertical situation. Horizontal and vertical lines, the equations or inequalities only have an x variable or only have a y variable. And you remember this memory trick to tell the difference? Hoivux. So if it only has an x, remember, like, compare this with just x equals 1. That's going to be a vertical line. So vertical lines, their equations or inequalities only have an x variable. And so we have a vertical line here. And it's going to be at x equals 1. So x equals 1, and we draw our vertical line. But is it going to be dashed or solid? It looks like it's going to be solid. Now, the foreshadowing now comes into play. We want to shade above or below, but it's a vertical line. It's perfectly vertical. Which side is above and which side is below? So this is the only situation where there really is no quote-unquote above and below. There's only left and right. Well, it's exactly what you probably are thinking. Below, it would, less than is kind of like left here, and greater than, we're going to go with right. So, above or below, and again, this is the only situation where you go left or right. Please, 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 please do not misunderstand what I'm saying. Left is not always less than. In fact, maybe I can even prove it to you. Oh, right here, I think. Notice how, above the line is also kind of left. So do not go with, oh, it's greater than, I shade to the right. No, 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 no. It's always above or below, because again, like, if you don't understand what I just said, then just look at this again. Go back in the video like 30 seconds here, and think about it. Right, you'll figure it out if you don't already see it. You only go with left versus right when it's a vertical line. And so this is less than or equal to, so we shade to the left. But you should always go with above or below once it's a vertical line. And that is that. So quick recap, unless you're dealing with a vertical line where there's like a little special consideration when it's a vertical line, but other than that, you pretty much just use mx plus b to draw your line, but you have to make it dashed sometimes, solid sometimes, depending on the symbol, and then you shade above or below, depending on the symbol.